What is the voltage output of a transformer used for rechargeable flashlight batteries if its primary has 500 turns, its secondary 7 turns, and the input voltage is 120 volts? So what are we given here? Let's look at the schematic representation of the transformer as follows. And you can see we have the primary on this side with a voltage of V sub P, and N sub P will be the number of turns of the primary. Here we have the secondary, and it has a number of turns of N sub S and voltage output of V sub S. With that nomenclature, the number of turns N sub P of the primary is 500 turns, that of the secondary N sub S is 7 turns, and the voltage input V sub P is 120 volt. And what we are required to find in A is what the secondary voltage is, or the output voltage is. So we know that the ratio of the primary voltage to that of the secondary is equal to the ratio of the number of turns of the primary to that of the secondary. Rearranging the equation, we have V sub S equals to the number of turns of the secondary divided by the number of turns of the primary multiplied by the voltage. Let's plug in the numbers. 7 will be the number of turns of the secondary, divides that by 500, which is the number of turns of the primary multiplied by 120 volt, and that yields 1.68 volt. B, what input current is required to produce a 4.00 amp output? So we are given current of the output, which is I sub S equals to 4.00 amp. And what we are required to find is the current of the primary. And now we know that the power input and power output are equal for an ideal transformer. And that is power input is equal to power output. And power input is equal to current of the primary multiplied by the voltage of the primary. And that will be equal to the current of the secondary multiplied by the voltage of the secondary. As power input equals power output. We have everything for except for the current of the primary. Therefore, we rearrange the equation for the primary. I sub P will be the ratio of the voltage of the secondary to that of the primary multiplied by the current. Just plug in the numbers. Voltage of the secondary is 1.68 volt. We have calculated this in A. And 120 volt is the voltage of the primary, which is already given. And with the given current of secondary of 4 amp, we get current of the primary to be 0.056 amp. C, what is the power input? What we are asked to find is the power input, and we know that the power input is a product of the voltage of the primary and the current of the primary. So P sub N is equal to IP times Vp. Just plug in the numbers. We have calculated current of the primary in B, and that's 0.056 amp. We are given the voltage of the primary, which is 120 volts, and that yields 6.72 watts. D, is this transformer step up or step down transformer? So we are asked to find the type of transformer, and that will be, there is a voltage drop down, that means it's a step down transformer. Since V sub P is greater than V sub S, that is, the transformer converts high voltage to low voltage. Therefore, this transformer is step down transformer. Thank you for watching.